Hello students, and welcome again to my channel. My name is Mr. Meshak Ngige and welcome to eMaths with Mr. Meshak Ngige. I hope that you are learning. I hope that you are sharing the videos, liking them, and also subscribing to this particular channel. Kindly, if you have not subscribed, consider subscribing to this particular channel as we learn together engineering mathematics. Now, so today we're going to be checking something called the directional derivative, that is on the topic of vectors, vector analysis. And by definition, directional derivative, the direction of a particular vector is given by d phi ds, which is given by a, then grad of phi, where a is defined by a is defined by a, which is a capital. We can just call it a vector over the absolute of that particular vector. So for instance, here our a here, the small a, will be given by a, which is this vector, over the we can call it the magnitude, right, of a, right, together. So now we can just work it out. So solution. So we know, since it is given, since the direction derivative is given by d phi ds, where by a grad of phi, so we can get the grad of phi. Remember, if you have not checked the video on gradient, the gradient question is given in the link given in the description box. Are we together? So d phi we have the directional, we are getting the directional derivative, where this one is the operator, then we have the function. So our function is given by phi. Remember, again, it is not a must that every time you're given your function in terms of what? In terms of phi. It can change to another letter. Okay, so this one will be given by it is given by d dx I plus d dy j plus d dz k, then of the function what? Of the function phi. So this means we're going to differentiate this particular function of phi. It is not dot, sorry. Differentiating the function, first of all, with respect to x, then we put I. With respect to y, you put j. With respect to k, with respect to z, you put k, right, together. So we can start with d, remember it is partial derivative, d phi with respect to x, then I, right, together. So d phi dx, so when you differentiate this function with respect to x, we have an x here, so we'll get what? 2x, then you have z. We also have an x here, so the x goes, you remain with 2y what? 2y squared, right, together. Then d phi, we come now to y, then j, again the same function, differentiate with respect to y. We don't have a y here, so we don't differentiate it. We come to this particular function, we have a y, so we drop 2, we have 4x, then you have what? Y. Remember, you're dropping the power, reducing the power by 1. Okay, do we have a y here? Yes, so the y goes, we said again, the y doesn't just disappear, right, together. We are reducing the power of y by 1. So it was to power 1. If we reduce it to power by 1, it becomes to power 0, and anything to power 0 is 1. So it is the same as saying we're going to have a 1 here, then multiply by z squared. So we just have z squared. Then the last one, we have d phi dz, then you put a k. Okay, so now with respect to z, so we have a z here, so the z goes, we remain with what? X squared. We don't have a z here, right, but we have a z here, which gives us what? Gives us 2yz, right, together. So those are your particular functions. Now in terms of I, j, and k, so we have I, then we have j, we have j, and here we have what? We have k. Now, again, I always prefer writing the points adjacent to what we have here. So remember, you're getting the grad with respect to what point? With respect to the point 1 to negative 1. So you're saying where you have an x, you put 1. Where you have a y, you put 2. Where you have a z, you put negative 1. So in this case, you can just have, so you can just work each term at a go. So I can say at point at point 1, 2, negative 1, what will be my value? Also here at point 1, 2, negative 1, what will be my value? And the same here at point 1, 2, negative 1. So what will be my value by the end of the day? So you can just do it together. So we have 2 times 1, right? Then times negative 1. 2 times 1 times negative 1 gives us negative 2. Then 2 times 2 squared. So 2 times 2 squared is 4. 4 times 2, which gives us 8. So plus 8, which gives us what? 6i, right? Then we have, again, we come to 4 times 1 times 2, which gives us 8. Then plus z squared is negative 1. So negative 1 squared just gives you 1. So you get what? 9j. Then the last one we have x squared is 1. Okay, so we have 1 plus 2 times 2 is 4. 4 times negative 1 is negative 4. So this one gives us negative 3k. So therefore your grad will be given by 6i plus 9j minus 3k all together. So that is that. Then we come now and get this particular value. So we have a, which is given by a over the absolute of a, the magnitude. So we are just saying what is our a? Our a value is this vector here. So it is 2i plus 3j minus 4k. Then over the absolute of a is given by the values of a squared and the square root. So over 2 squared plus 3 squared plus negative 4 squared, then you get the what? Get the square root. So again, this one is 2 squared, which is 4. This one is 3 squared is 9. So we have 9 and we have 16, it gives you 25. 25 plus 4 gives you 29. So it is 1 over root 29. Then I can just take 2i plus 3j minus 4 minus 4k. Okay, so we have that part. So therefore the last part now is getting now our a, then the grad of phi. So what is our a? It's given by this. It is 2i plus 3j, and it is dot, it is a dot product, minus 4k. Okay, we have that. Then remember we have a constant, so we can choose to have a constant at the beginning. I can okay, I can just have it here, equals to 1 over root of 29. Then I dot it with what? I dot it with a grad. What did you get as our grad? 6i plus 9j minus 3k. Are you together up to that point? Right? So now these are dot products, as we said. So remember here, that is a dot product. Sorry, I had not put that. So remember in dot product, so it is 1 over root 29. Okay, in dot product we said, if you have not again checked the video on dot product, we said when you dot I, you only dot i's and ij and jk and k's, but I dot I, j dot jk dot k gives you 1 by the end of the day. So we're just basically saying multiply the terms at the same position and add them. So 2 times 6 gives you 12. Then plus 3 times 9, 27. Negative 4, negative 3 gives you plus 12. So these and these gives you 12 plus 12 gives you 24. 24 plus 20, or 24 plus 27, that gives you 51. It gives you 51 over root of 29. And what is the answer to that? So the answer to that will be given by, sorry, today I forgot my calculator, so we shall just have this one will work for us, divide by the root of 29, and my answer will be 9.4705. 5 into 4 decimal place. So basically, when you're working now with something called the directional derivative, what you just need to understand again is what? It's just the formula all together. So you need to know it is given by a, then dot product of the gradient. So you'll get the gradient, you'll get a, where your a is given by a, then the magnitude of a, so given by that. So you'll get that particular vector. So this part will be a vector, this part will be a vector. So when you dot them, it will be a what? It will be a scalar, because when you dot two vectors, it gives you the scalar as the outcome. All right, so therefore this, then we have that, and we get our answer.